Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com webinar, brought to you by TechStrong. My name is Cody J. Brown, and I will be moderating today's session. We have an exciting presentation ahead of us, but before we begin, I have a few housekeeping notes. Today's event is being recorded, so if you miss any or all of the discussion, it will be made available to rewatch. You'll receive an email after the webinar concludes with a link to access the on-demand. We want to hear from you, so please feel free to send in your questions at any time throughout the program. Just use the Q&A feature on the right side of your screen. We'll try to address as many questions as you guys can send in, so please be sure to get them sent in early. We also encourage discussion by using the chat tab, so just let us know your thoughts or say a quick hello. Finally, at the end of today's webinar, we have a drawing for 4 $25 Amazon gift cards, so stick around to see if you're one of our 4 lucky winners. But let's go ahead and kick off our webinar. Our topic today is Observability-as-Code. Go faster with automation using Terraform and Splunk. And I'm joined today by Amit Sharma, Director of Product Marketing at Splunk, and Cole Morrison, Developer Advocate at HashiCorp. At this point in time, I'll turn the floor over to our panel. Amit and Cole, thank you so much for being here with us today.
All right, thank you, Cody. And thank you, everybody, for joining. Welcome again to this webinar, Observability-as-Code. So we're going to be talking about Terraform and observability, as well as Observability-as-Code. How do you drive automation? So a little bit about myself, introduction. So I do product marketing at Splunk. Before Splunk, I was part of SignalFX team. And SignalFX is a real-time cloud monitoring company that Splunk acquired almost about 2 years to the date. Before SignalFX, I was in the same role at FD, and before that at Cisco in container networking and cloud business units. So I have a fair bit of experience in monitoring observability space, but the majority of my career has been as a software engineer. So I was in your shoes. I carried the proverbial pager. I was responsible for maintaining and running my applications in production. So it is very relatable to me as we are looking at how these products can help in SRE functions today. So we are delighted to have Cole Morrison from HashiCorp. Cole, do you want to introduce yourself?
Yeah, sure. Thank you, Amit. So my name is Cole Morrison. As Amit just stated, I'm a developer advocate at HashiCorp. Now, I've been in the tech industry for some 10-ish years, mainly in software engineering and development as well, though the previous 4 years have been in DevOps. Now, I would love to put a whole long track record up on my slide here, but because a lot of my time has been spent in startups, many of those startups no longer exist. But I have a lot of experience in Internet of Things, so IoT, doing a lot of scale there, doing some high data infrastructure around forms, so it's kind of like TypeScript if you think like that, and of course teaching DevOps as well, which of course is its own thing because teaching it always forces you to learn it pretty well. So yeah, that is me in a nutshell.
All right, fantastic. It's great to have you here. So Cole and I are going to tag team on this, so we will be going back and forth in different parts of the presentation. But let's talk about what we have for today. So in the spirit of Terraform plan, this is our agenda. So we'll talk about infrastructure as code. How do you accomplish that using HashiCorp Terraform? And Cole has a demo on that. We'll talk about observability, how observability is different from monitoring, what makes up observability. I want to introduce you to a product, a metrics-based real-time monitoring product called Splunk Infrastructure Monitoring. And then we will get into observability as code, and I have a demo as well. And we will have enough time towards the end for answering any questions that you may have. So with that, let's dive in. Cole, do you want to share your screen? Let me stop sharing.
Yep, that sounds like a good plan. So we'll just swap screen shares here. So let me go ahead and put mine on and tell me if this looks good. Does it look good? Can you see it?
It does.
Awesome. All right. So obviously this presentation is named Observability as Code, but you can't observe what you don't have, right? So this first part is going to be on infrastructure as code, Terraform, and a demo like we just saw. Now, I've been working with infrastructure as code for so long at this point that it's kind of hard for me to imagine a workflow, let alone a world without that around. But I know for a lot of us, whether by choice or necessity, we're still doing things the old way. So in this first part of this presentation, right, so on infrastructure as code, we're going to speak about it from a higher level so you can understand the problems that it solves, the benefits that it gives, and hopefully give you another thing to your mental toolbox so that you can make some better solutions going forward. So let's look at the agenda of what we're going to be covering here. So the first part, we're going to cover some basics around infrastructure as code for those of you that have heard this term passed around but may not know what it is in depth. Then we're going to find some depth in the topic by talking about the problems it solves and the like. We're going to look at Terraform and how what its role is in writing infrastructure as code, followed by a demo where we're going to stand up an AWS EKS cluster, so a managed Kubernetes cluster on AWS. And then we'll, after that, talk about scaling both your workflows and the infrastructure and context of infrastructure as code and next steps. So let's go ahead and get into it. So we're going to talk about infrastructure as code, but first let's talk about infrastructure without code. Now, without it, you're probably doing a number of things, right? You're probably clicking around in user interfaces, shell scripts, gluing together bash scripts and the like, and using configuration tools like Ansible. But here in 2021, you're probably doing a mix of all of the above. And there's nothing wrong with this at all. I've seen some really neat magic from some of the ops professionals out there in terms of what they can do. But let me ask you something here. When it comes to something like replicating your infrastructure as it is to a different purpose, or repurposing it for an entirely different project or team or anything else like that, or what about tearing it down? Well, that's probably the most unfun Easter egg hunt you'll do when you go to do it because you don't want to step on someone else's toes. And then documentation. I'm not going to go any deeper there because we know how much of a pain that can be to both write and read. And then the last one here is one I like to bring up for both a business and personal case, and that's reusing the patterns you have for your current infrastructure in different projects and, of course, different infrastructures. Because as we know, the older and the bigger an infrastructure gets, the more unique it becomes, and therefore what you do there may or may not be applicable to other infrastructures, right? So I've only got a few problems here with infrastructure without code listed, but pretty much any problem you can think of about your infrastructure without code is solved by infrastructure with code. So let's go ahead and talk about infrastructure as code now. And what is this? Well, in a nutshell, it's when you define your infrastructure, so servers, networks, security policies, the whole thing in code. I'm not trying to be glib. I know that it sounds like, oh, well, yeah, it's infrastructure as code, but it's beyond the obvious. What it is it's an entire umbrella of ideas and workflows, right? See, the thing is, when you start defining your infrastructure as code, you get all of the benefits of it being code. And if you've kept up with software development at all over the past years, well, really just in general, you know that there's so much wonderful tooling, so many well-defined workflow patterns for both the individual and teams that are out there. I mean, you just think about like some of your just basic text editors like Visual Code Studio and how much power you have for those. Well, when you start defining your infrastructure as code, all of those benefits are right there at your fingertips that you get to take advantage of. And there's something beyond that too. There's a different way of thinking about it that pops up when you go towards this path. Prior, if you look at your infrastructure without code, you're probably, taking step-by-steps for certain shell scripts you run or shell commands you run or things you do in the UI. And you're really focused on the how you're getting to that end destination, whether that be, a fleet of servers or something else. But when you move to infrastructure as code, assuming you pick a good tool, you start instead thinking about the end result. You say, here's what I want. All right, cool. Now I'm going to hand it over to you to something like Terraform, and Terraform is going to go and make it. And so that allows the mental model to switch from something that's imperative to something that's more declarative. Now, I could rattle off a ton of other benefits here, but really, if you think about any benefit you get in working with code, that's something that you will immediately get to your infrastructure, which is why I can't go over all of them. But there is one benefit that I did want to take some time to explain, and that's infrastructure as code in context of a version control system, so something like GitHub or GitLab. Now, this is where the benefits for this really, really take off, because if you've kept up with things, then when things like GitHub and GitLab popped up over the past decade, they really changed the game in terms of how teams collaborate and the productivity and power that they can get by taking advantage of those systems. And that's something you get right with your infrastructure. So being able to version, collaborate, fork, and promote all of that entire buffet of functionality is something that you get immediately. So you may have one branch that represents your production state of infrastructure. And then you might have another one that represents different states, stages, or versions of your infrastructure without having to worry about them conflicting with each other or compromising one another. So for a little bit more practicality, what does this look like in terms of just an example here? Well, if we were using Git, for example, we might have a production branch that is deployed live. And let's say we want to make some changes to that. Well, we would just check out a new branch, make our changes, deploy them, make sure that they're good, ready, and done. And then once we're satisfied with all of those changes, merge them back into our production code and move forward. And so this gives a very well-defined workflow, because it's not like we're having to come up with something home-baked. We're using something that's well-defined and has been used in software for some time. So we get all these mature processes that are with a VCS in our infrastructure as well. Okay, and of course, if you got your GitOps chops on up to date, right, then you know that every time you do something to a branch on GitHub or whatever provider you're using, there's a lot of magic that you can do both before and after those merges or different pull requests happen. Okay, so concepts, how do you get this done? Well, of course, the first step is to pick a good tool, and in my case, it's going to be Terraform. Now, in terms of explaining Terraform, pretty much all the benefits I just rattled off are what Terraform give you. So I could say them all again, but there's not really a point. What I want to focus on here is more of the workflow that it gives you. And the workflow that it gives you as a practitioner is you go and you define your infrastructure as code, whether that's code you write or code that you pull down from, say, our public module registry, where we have well-defined patterns already made for you. So for example, we'll see later defining a virtual private cloud, so a VPC up on AWS. You can do that by hand, or you can just use a module that we have for you. And the way that this looks is after you've defined that code, you're going to run two commands with Terraform. You're going to run plan to see what's going to happen, and then apply to go forth and make all of those things happen. And that's it. So, I mean, I can sit here and give you all sorts of jargon and sprinkles and all sorts of other things, but at the end of the day, that is what it's getting you. It's removing a whole entire cognitive load that otherwise goes towards, piecing together step-by-steps in different scripts and understanding messy control flows. You get this idea where you have this infrastructure as code just set as what it is that we need. You pass it to Terraform. It says, all right, cool, I'm going to go make it, and you're done. So that is Terraform very quickly, but let's take a look at what you'd actually be doing when you go to write it. So when it comes to Terraform and we say infrastructure as a code, we should probably take a look at what that code is like. And so here's a very simple example. When Terraform, you write your code using HCL, so the HashiCorp configuration language. And, we don't have enough time to go in depth of what HCL is, but let's not even do that. If you're looking at this little code block here, I just sort of want you to fuzz your eyes and kind of look at it from a common sense perspective. And you can probably make out what's going on, right? We've got a variable here that's defining a base CIDR block. Then we have a GCP network, and then we have a GCP subnetwork. How many do we have? Well, we have 4. And then as far as each of the CIDR ranges that they'll have, well, we're using this built-in function to give it a unique CIDR range based on the count and based on the original block. And the point that I want to make there is that in just a handful of seconds here, you've read, and there's a lot of clarity around what is happening. The second thing, in HCL, it's made for configuration. It's made for infrastructure. So a lot of the features we have built into this language are going to improve your productivity because they're meant for what you're doing. Right? So the other thing too is what you see here is what you get. So what you see is what's going to go up and be live. And we actually draw up a relationship between the resources in your code and what's live on the cloud as well. And of course, I wouldn't say the best part, but a very nice feature is when you go to wipe all of this out, just using Terraform destroy, well, that Easter egg hunt of hunting down resources goes away because, well, it keeps track of all of them for you. So it's a very painless process. Okay, and we'll obviously talk a little bit more about that when we get into the demo. Now, Terraform is a mature tool, which is why I'm using it, among other reasons. One of those reasons being that I work at HashiCorp. But to be fair, I was using it far before I started working at HashiCorp. Now, stats are stats, and I'm showing this page not to like brag or blow it up, but just I know that as in the tech industry, whenever we go to choose a tool, we always have to do it with the lens of, is it going to be around? Does it have community support? And is it mature enough for me to use? Well, just this past summer, we launched version 1.0, and version 1.0 stabilized every critical and core feature. And as you can see from the numbers here, we've got a lot of community support, and it is going to be around for the long run. So it's absolutely something you can invest your time, your skills, and your resources into. All right, so let's get into the demo just for time here. So what we're going to be doing today is deploying an AWS EKS cluster, and we're going to do it all in Terraform, and we're going to do it all in a handful of minutes. But just for giggles, I want you to imagine what setting this up would be like if you were doing it without code. All right, you can stop there because it probably wasn't very fun. And then if you return to modify it like 6 months later, that's going to be an entirely different adventure, right? And yeah, we're going to get this done, like I said, in a handful of minutes, assuming we were to take out all talking I'm going to do. So I'm going to put these slides down here, check the webinar room to make sure that I'm still in it. Yes, perfect. And we're going to head over to the code. So this is my demo code project here. So when you're getting started with Terraform, it's super simple. You're going to download our binary, you're going to pick a directory, and you're going to start making .tf files. And that's it. That's all you got to do. And when you run your Terraform plans and your applies, the two bread and butter commands, it's going to look through all these files, grab them, put them all together, and go and make your stuff. Now, something when I came in at least was like, well, wait, what about the order? Now, don't look at anything in the file here. Instead, just sort of fuzz your eyes. But whenever I open up code, I'm like, well, should this be at the top or should it be at the bottom? Should it be in the middle, et cetera, et cetera? Well, none of that matters. Terraform is smart enough to figure out the relationship between your different resources that you define, because one of the things it does in the background is create a dependency graph to figure out those relationships for you, so you don't have to worry about order, which, as you know, if you're doing this without code or with bash scripts, well, that's order. And race conditions are absolutely something you have to think about, but Terraform takes care of that for you. The other thing too, and like, how does that work? Well, if you define, like, say, a server and a firewall, and the server uses the firewall, it's smart enough to pick up, well, the firewall should probably be created first. Okay, so let's go into this versions.tf file. And again, this could be named whatever it is that you want, because we give you a lot of freedom and flexibility in terms of how you structure your projects. And the first thing here I want to take a look at are these providers. Now, in Terraform, providers are like the diplomat that let Terraform communicate with external services and external APIs. In this case, we've got 5 defined. One is an AWS provider that's going to provide us with the ability to define AWS resources. One's a Kubernetes provider down here that's going to provide us with the ability to speak to a live Kubernetes cluster in Terraform. And then we have some smaller ones in here that are instead going to allow us to speak to code and get their functionality. So for example, this random provider is going to let us generate UUIDs in strings. And there are over 1,600 of these providers. So if you just pause here, you can say, wow, I'm going to work with AWS and Kubernetes in the same code base here. But let me hop over to our registry. And in this registry, we can see we've got 1,600 providers. And if we were to go and browse through all of them, this means that you can work with all of these different things. Let's see, what's a good provider here? What about the Splunk provider? You can work with Splunk or any of these different ones right in the same code base. So that's what providers do for you. And specifically, they provide you with resources to work with. So once we pulled in this AWS provider, for example, we could go and start defining security groups. So I'm going to just open this up here, and we'll talk about resources some. Now, looking through this here, well, if you just sort of read it kind of like how we did the first example with HCL, you don't really need to know HCL to understand it. We know that this is probably a resource. It's probably making an AWS security group. We've passed it a label that we want to refer to it as. And then inside this block are just all the settings, like a prefix, what VPC it's going to belong to, and then just an ingress rule that's just saying from port 22 to port 22, right? So even without learning HCL, it's pretty simple, but just so you know, this is a block type. These are block labels. And then within the body, we have arguments, which is how you customize the resource. So when you pull in a provider, it gives you access to all of these different resources that you can use. So if you're wondering, well, what resources can I make? Well, if we head just back over here, we know that we have the AWS provider. So if I click into that and go to documentation, you'll see here down the left of the page, these are all the resources that you have access to. So if I search for that AWS security group, go and find that down here at the bottom. Here we go. We'll see that we have an example for how we can use it, the arguments, which is how we can customize it, and the attributes, which of course, how we can reference it in other parts of our code. So cool. Let me hop back over to the code here, and let's go take a look back at that VPC file, because I know there's a lot going on here, and we're not going to be able to cover all of it just due to time. But now that you've read through that, it's probably obvious that this is a variable, so something that we can change for our own purposes, and we see it being used here. We have a provider block here, which lets us customize the settings for a provider. We have a data source block here. And what this data source is, well, a resource, like we saw over here, is something we go and we make through the provider, whereas a data source is something we go and it's information we fetch from the provider. So in this case, it's fetching the availability zones for our region. We have locals, and that's just for reuse and compute. Resource, we've seen this before. And then down here is a module, and this is what I really wanted to spend the time on. And so for the module here, what it's doing is it's going and creating a VPC on AWS for us. Now, if you've made these before in AWS, that is a lot. It's a lot of just sort of boilerplate work, right? Yes, every network's going to be different, but a lot of things are the same. And what this module is doing, and it's giving us the ability to pass some settings to it and then have all of these things made for us. Now, if you're familiar with any type of programming language, you understand the idea of modules, just abstracting away some code so that we can use it elsewhere. Well, modules in Terraform are the exact same. So where do you find these modules when you want to go and save yourself some time here? Well, let's go over back to the registry. So I'm going to go back to the registry. And we'll see not only does the registry show us all the providers, which are, again, how we connect to these external services, but also the modules. And the modules are those reusable pieces of code. And if we browse through them, oh, look at that. The VPC one's right at the top. And we'll see that it's a verified one. So something that we at HashiCorp vet and make sure is good and working. It's been used some 14 million times. And you'll see some documentation for every module, how you can customize it, how you can reference it, and then all of the resources that it makes. And obviously, there are a lot that you would have to make otherwise. So this is going to be a big time saver for you. Now, continuing on with modules, let's head back over here and go over to our EKS cluster. Hopefully, with all of that said, what's going on here makes a little bit more sense, right? We've got this module that's called EKS, so we can refer to it locally. We're pointing it to a source. Well, what source? Well, by default, when you specify it like this, it's going to go look on the registry for this module. So we could go and check that out. I'm going to go search for EKS. Here we go, and we'll see the same type of format, how we can customize it, what we can reference off it, and all the resources it's going to make. And then through here, all of the specific settings for us. And we'll see some other cool things in here, such as the fact that we looked at that security group and we're referencing it right here. And we also made that VPC module and we're referencing it right here as well. So just to pause there, that shows that modules, when you start working with those, give you the ability, especially if you're multiple teams working on a single infrastructure, to develop the different pieces of it separately, right? And of course, that separation of concerns is going to come with a ton of other benefits as well. And the other thing I want to point out is we looked at that demo, right? And if you tried to ideate how we might go about setting that up, you probably got a tiny headache. Well, we're going to do it all here, right, in about 35 lines of code. And the beauty of something like a module when you develop it is when you have an architect come in or maybe a junior that just needs to look through the code, they don't need to understand all of the nitty gritty to figure out what's going on. Okay, so just for moving on, let's go ahead and see what do you do to get this all up and alive. So I'm over here in my shell, and the first thing you're going to do with every Terraform project is do a Terraform init. And what Terraform init is going to do is it's going to pull down all the module code and all the provider code that you need for your project that you've specified within it. And it's also going to set up everything else it needs for Terraform to treat this as a project. One of those things is a state file, but we'll talk about that a little bit later. So there we go. Terraform's been successfully initialized. The next step is a Terraform plan. Now, Terraform plan is going to show you every single thing that Terraform is going to do for every single thing it's going to make. So let me just give it a second here. And there we go. We can scroll up and see every single resource it's going to make. Now you're going to see some values like known after apply, and that's because, well, you can't know the ID of a resource before it's created, so we won't know that till after. And the rest of the values are either sensible defaults that we've gone ahead and set for you through the provider, or values that you've specified yourself. Now, once you're done with Terraform plan, you can use a Terraform apply. Actually, before I do apply, I'll go ahead and run it here. But the beauty of a plan, I know that at first glance, it's just like peace of mind. But the amazing part is it gives you the ability to scrutinize every change in your infrastructure before it goes live. And if you're on something like Terraform Cloud or Terraform Enterprise, we have our policy-as-code tool, Sentinel, that you'll be able to use, that you can then set up guardrails and say like, hey, whenever someone tries to come and change your infrastructure, let's make sure they're not leaving an S3 bucket wide open, because we don't want to be in the front page news. All right, so you do your apply, and it's actually going to show you the whole plan again. So if you wanted to, you could just skip the plan and just see the plan here. And when you're ready for it, you would just type in yes, and you'd be good to go. Now, I'm not going to type in yes, not because it won't work, but because an EKS cluster can take anywhere from 10 to 15 minutes to provision. So I'm actually going to go ahead and do no. I've actually gone ahead and gotten it up for us. So if we were, so I have another identical repo here where I've gone ahead and run Terraform apply. And if we were to head over to the AWS console, we would see that we have a VPC made, and we have an EKS cluster made. And of course, we have our EC2 instances made, or our worker groups here. Cool. So that would be that. Now, once you're done, this is the nice quality of life thing. You could run a Terraform destroy. And Terraform destroy is going to follow a very similar pattern in the sense that it's going to show us a plan again and be like, yo, this is what we're going to go and delete. Are you sure? And then you can confirm yes or no. And the reason I bring that up is to point out the fact that we are not playing that Easter egg hunt thing, right? It knows, it keeps track of the relationship between everything that's been made so that it can go and hunt those resources down and delete them without you having to go through and do it yourself. So the last thing I want to touch on here over in the code, let me hop over to the version that's finished, is this state file here. Now this state file, we touched on it earlier. This is how Terraform keeps track of the relationship between the resources you have in your code and what's live in the cloud. If you're coming from CloudFormation, you're probably thinking in terms of templates, but with Terraform, what you have in your code here is the source of truth. It is what is up there. So if I were to come here and change the security group and run Terraform apply again, it would change it up there. Now the state file is something you need to keep secure and locked down. There are many different ways to do it, but of course the recommended way is to just use Terraform Cloud, which we're going to talk about here in a second. Okay, so let me head back over to my slides here and go back in. So that was largely infrastructure as code and Terraform in a sizable nutshell. But what we didn't cover, aside from all of observability as code, is just hitting scale. What happens when you need to take those next steps? Because I'm not just talking about the size of your infrastructure, that's one part of it, but also for your team size, your code base size, your processes and the likes. Well, when that happens, that's where Terraform Cloud really comes into play. Now, don't get me wrong, as far as the open source version goes, you can take that all the way to the moon, and we have a lot of customers and practitioners that do that. But if you want to focus on what makes your business or your project unique and valuable, then this is definitely something to look into. It's going to unlock an entire world of convenience around infrastructure as code. Now, as far as what it unlocks, well, one of the things we talked about was, setting policies and the like, but it also allows you to add webhooks to run more checks on your code, detailed logging, a private module registry. It locks down that state file for you, and we give you a lot of well-defined patterns around how to work with teams, around teams and more people, because that's always a problem once you start adding more people to the same code base. And by the way, this is free for the first 5 users, so there's really not a reason not to start using it from the get-go. So be sure to check it out. And of course, if you need more information, we've got our main site, the Learn platform. It's got a ton of great guides, and the registry. And as for what else we didn't cover, well, how about all of observability as code in general? We've got the stuff set up, but it's not as if Terraform starts just giving insights into that to the level that what Amit's about to show us. So with that, I'm going to pass it back over to Amit.
All right. Thank you, Cool. That was fantastic. Let me turn back on my camera. And Cole, if you can, please go on mute and turn off your camera.
Sounds
And
good.
I'll start sharing my screen. Perfect. I think you guys can see this, right? Let me maximize this. Fantastic. So let's talk about observability and why observability is so important as we get into cloud and cloud native architectures and microservices-based applications. So pretty much all of us know that companies are modernizing their infrastructure. They're adopting cloud, they're adopting containers, things like Kubernetes and serverless. They are also modernizing their applications. And the primary reason is speed, agility. This is a good stat from Gartner saying 75% of global organizations will be running containerized application. Now, this has accelerated. Then just concluded CNCF or KubeCon, they found out that 92% of organizations are adopting containers in production. Now, granted, that is self-selected crowd. People who are going to KubeCon, they are obviously adopting containers. But that number, 92% in production, is up from 30% in 2016. So just astonishing adoption of Kubernetes containers and cloud native technologies like serverless. Now, let's take a look at the paradigm shift in computing, right? The infrastructure point of view. So we came from physical machines, where it's pretty much rack and stack sort of system. You have to guess how much do you need, capacity do you need, heavy capacity investment, initial capex. From there, we graduated to virtual machines, which is hardware, provides us hardware independence. It provides faster provisioning. If you're running in cloud, you could do capex to opex. It'll give you elasticity as well, and it's faster to provision. Now, from there, we are now adopting containers, which portability is a big benefit. So it gives us platform independence. It is consistent runtime. A Docker container or containerd will work exactly the same as it does on AWS to Google Cloud to Azure or on-premises cloud. It gives us high resource utilization because you can bin packing. You can put more number of containers within the same node. It gives us isolation, easier and faster deployments, starts up within seconds. And Kubernetes specifically gives us it's a self-healing mechanism, right? It increases our DevOps productivity. And finally, we are looking at serverless. So it is continuously scaling. It comes closest to the pay for value or the usage that you're using. You're no longer paying for infrastructure. So we have seen infrastructure is evolving. We have seen applications are evolving from monolithic applications to microservices-based applications. And there are benefits of both of these modernization efforts. How about monitoring? If everything is evolving, traditional monitoring no longer works. So observability is also need to evolve. Monitoring needs to evolve from traditional bottom-up investigation of individual layers to top-down directed troubleshooting, considering system as a whole. Especially true for distributed systems such as Kubernetes and microservices environments. Now, it has to evolve from limited cardinality in a static word, like before word on the left-hand side, to high cardinality analytics. From slow batch inquiry systems to streaming monitoring and alerting, which can detect problems in seconds rather than taking minutes or tens of minutes, which is used to do in the static word. And finally, sampling data due to scalability issues. So in the previous word, we used to sample. We would batch data and then send it to our monitoring system, which then pulls their systems and then present us with dashboards and alerts, which will take minutes, tens of minutes. Here, we are not sampling. We need all the data to avoid blind spots. And lastly, the data collection. Now, data collection has been commoditized from proprietary heavyweight instrumentation to open source, open standards-based approach such as OpenTelemetry. Modern observability is all about data. Now, by now, you must have heard three pillars of observability, which are metrics, traces, and logs. Metrics help you answer the question, do I have a problem? And they are very useful for real-time detection and alerting within seconds, particularly with distributed large systems. They are critical for keeping an eye on SLIs, and key performance indicators that you are monitoring. Now, traces helps you understand where the problem lies. You have a complex web of microservices, multiple tens, hundreds, thousands of microservices. Traces are very helpful in exploring and troubleshooting upstream and downstream service dependencies and user transactions. And finally, logs. Logs have most context, and logs provide the details to help you dig deeper, understand why the problem is occurring at the first place, and what you can do about solve that performance anomalies. Altogether, and when effectively correlated, these three data types can help you answer any questions that you can ask to your observability system. It can provide you the full stack visibility across all the layers of your infrastructure, container platform, container orchestrators such as Kubernetes, and microservices-based applications. The requirements for observability in the modern world is all the data. We talked about no sampling, all types of data, metrics, traces, logs, and from all sources, from infrastructure, container runtime, orchestration, and microservices. Real-time analytics. So you need answers in seconds, like as it is happening. Now you may ask that, hey, in the middle of the night at 3 a.m., I cannot orient myself. Seconds don't matter, but seconds actually do matter. They matter because we can automate all but mundane tasks, right? Most of the tasks that we can, including the responses to performance anomalies, we can automate. And if your observability system is not capable of detecting issues in seconds, you cannot respond in real time using automation. Finally, we have seen these distributed architectures such as Kubernetes. In Kubernetes, even if you start a pod, like one Kubernetes object pod, it might instantiate, it might create multiple objects on the back end, like 50, 60 Kubernetes components on the back end sometimes. Things like namespaces, load balancer, services. Your microservices might need network interfaces or storage. So just mere creation of a pod may result in 50, 60 Kubernetes components. And all this data is coming in with a high cardinality to your system. So your observability system should be able to scale and provide real-time visibility at scale using high cardinality analytics. And finally, directed troubleshooting. So all this data is coming in from different types of sources, metrics, traces, logs, from across the stack, like from entirety of the stack. It's just impossible to make sense of this data manually. So your system should be intelligent enough, should leverage data science or machine learning to make sense of this data and do so in real time. So I want to introduce you to Splunk infrastructure monitoring. Splunk infrastructure monitoring is the real-time visibility or metrics-based monitoring platform, which gives you visibility into the entire cloud stack, your infrastructure, container runtime, Kubernetes, as well as RAD metrics from your microservices. So it provides on-prem and hybrid multi-cloud monitoring. So it can be deployed on Linux, Windows, VMware-based on-premises cloud, public cloud such as AWS, Google Cloud, Azure, Kubernetes implementation like EKS, GKE, or OpenShift. So any Kubernetes implementation can give you serverless monitoring, so Lambda monitoring, Google Cloud Functions, and such. Automatic service discovery. So it can automatically discover the components of Kubernetes, but also what is running inside the container. So things like Redis, Cassandra, Kafka, technologies that you use every day. So we have almost 200 plus integrations of these popular technologies, and accurate alerting in real time. So we will not have time to go into detail into all the functions or capabilities of Splunk infrastructure monitoring, but I want to touch base on one point, which is the real-time metrics-based architecture, and which is an amazing differentiator in the market. So here I'm showing you what a traditional batch-based metrics architecture, how does that work? So we have something called time series database, right? So by V means traditional monitoring based approach. So TSDB is there. And then on the right-hand side of your screen, we have analytics, visualization, alerts, automation, data science, different components that will make up a monitoring platform. And these components will periodically poll the time series database, and they will update their state. So it will take minutes, especially at scale, for dashboards to refresh, alerts to fire, automation tasks to trigger in the traditional batch and query-based architecture. Contrast that with Splunk infrastructure monitoring, our approach, our architecture. Now, there's a lot of things going on with this slide, but I want to talk to you why we built it this way, and then second, how do we accomplish real-time visibility? So why is basically, ultimately, observability is not just putting up pretty charts on wall TV. Observability is putting yourself in a position to anticipate problems. It should really be about interactive visualization. You should be able to explore, query, understand your system. Now, it should enable zero lag alerting. So performance anomalies, as soon as it happens, your SREs or operations team should be able to know about this. It should be alerted on that. Now, how do we do that? So we have several patented innovations. The way to read the slide is from left to right. So we will separate the metadata to data value at the front door. So as soon as a metric arrives in our system, we'll separate metadata to data value. Now that allows us to scale these two systems separately. Metadata are things like your Kubernetes labels or tags or properties, things that you need to slice and dice. Things like this, whether this application is in dev or QA or production or pre-production, which availability zone or which region, which cloud, which team, right? All these things are needed to understand your system. So you have big explosion of metadata or dimensions to your metrics. So we separate metadata from data value, and we can scale these two systems separately, and that's how we could do high cardinality. We can support tens of thousands of dimensions per active metric time series. So we can provide not only high cardinality, but in real time, analytics on that in real time. Now, second, we would do rollups. And we would also adjust for jitter, which is inherent to any cloud-based system or any system which has network. And thirdly, we will put all this data into persistent storage, but we do that in a way that you can look at the data which is currently coming into your stream, as well as historical data, so you can find out how many widgets did I ship last Black Friday, or compared to this, or what was the performance of my system before I put this new release in. So these sort of things are real time, comparing your current data with your historical data. And finally, the data as it coming through and passing through the entire system, it is streamed to your dashboards and alerts and automation tasks. It's not polling, it's streaming to these components. So your dashboards will refresh within seconds. Your automation task will trigger within seconds. Your alerts will fire within seconds. So that's how we do real-time visibility into your entire system. Now let's talk about how do you implement observability as code. Now, one of the best practices is to manage observability assets. We talked about dashboards, alerts, detectors, which are alerts in Splunk infrastructure monitoring. In a similar way, as part of your DevOps tool chain. So Cole talked about infrastructure as code. He talked about various providers. One such provider is Helm provider in Terraform. So you can install our Splunk infrastructure monitoring open telemetry collector as a Helm provider using Helm provider. So as you're putting up your EKS infrastructure, EKS cluster, you can also code monitoring or observability as part of code. And we will take a look at that. Now, to make it possible, we have Terraform Providers as part of official registry, and Cole was showing it, Splunk provider on the website. So we have Splunk, and SignalFX is our metrics-based platform, and VictorOps. Now, why should we implement observability as code? The idea behind observability code is same or similar to infrastructure as code. And that is to develop, deploy, test, and share observability assets such as detectors or alerts, dashboards, etc. as code. Now, doing so is important because it provides us with automated, repeatable assets. Now, once I develop dashboards or charts or alerts, they can easily be deployed, destroyed, or recreated as needed in different environments. And by doing so, we have eliminated the toil, right? We no longer will have to create those assets manually. Now they become shareable best practices. Now dev teams can leverage their domain-specific knowledge to identify the most appropriate metrics to monitor the performance of those applications. And it makes us more DevOps more collaborative. Now, by leveraging, we can put it into Git repositories. Observability assets can be created and fine-tuned by anyone in our organization with a simple pull request. One last thing before we jump onto demo is, so fine, you are now using HashiCorp Cloud. How do you operationalize it? There's a new Splunk-based application called Terraform Cloud for Splunk. It makes it easy to operationalize Terraform using a new API service called Audit Trail. Now, this JSON-based API opens up the ability to receive audit events for the entire organization. Now, from speculative plans to cost optimization using Sentinel policy. Sentinel is a policy as code approach to token creations. Splunk Apps gives you out-of-box real-time visibility into things like which workspaces generate the most frequent changes, which Sentinel policies are being evaluated most frequently, and which users are more active. And then you can slice and dice and find out for your own analytics. How are you deploying infrastructure or applications? Now, with that, let's jump to a quick demo. So in demo, let me first show you what is Splunk infrastructure monitoring. So here, what you're looking at, again, is Splunk infrastructure monitoring is monitoring your entirety of your cloud stack. So starting from your infrastructure here, we are looking at EC2 AWS integration. So you have a fleet of EC2 instances here. And it is giving you at a glance view of how the entire fleet is performing. You can easily, we talked about real-time architecture, you can easily see, you can group by, or you can slice and dice and filter and sort. And it is happening in real time. How quick was it, right? Within less than a second, right? It changed from the entire fleet to group by availability zone. You could do by service or service ID, so on and so forth. And these are the entirety of your EC2 fleet. You can easily take a look at this, and you can create an alert or detector, what we call. Basically, you can look at any of these metrics, and you can create an alert on that particular metric. We support sophisticated data science-backed alerting algorithms, things like resource running it out, predictive analytics, outlier detection, sudden change. For example, if you are running your own Kubernetes control plane and there's a huge change, increase in your in the Go routines, so you know that there is something wrong. You can create an alert on that. Historical anomaly, how your application has been behaving similar on a similar time window. So if there is a sudden change, that may not be actually an anomaly. That is how it behaves on a weekday as opposed to a weekend. And then you can send those alerts to recipients, things that you use every day, right? Email, Microsoft Teams, PagerDuty, Splunk on-call, Slack, etc. So now with that, let's take a look at observability as code. And we are going to deploy a bunch of charts in a dashboard group. Now the dashboard group is a user dashboard group right here. And I am looking as my own user group. Right now we have these dashboards, but I want to create something else, something new from scratch. So for that, I have created this code, and it's going to create all these charts. Now, this may look a little bit intimidating. How do we know what is the program text? I will show you an easier way to do this from within the UI. But let's take a look at one of these charts. For example, this one, or rather this one, where we are comparing latencies. We are looking at minimum, maximum, and P50 latency. So this is important, right? So this is what it gives. This is what it tells Signal Flow, which is our analytics engine, what to publish and what chart to create. So we have created this line of code. We can start from UI and get to this, and I'll show you in a little bit. Let's take a look at that here real quick, the Signal Flow program. Take any chart and, like, for example, this, open this, and we have something called view signal flow. So this is that text program, right? Program text. So here's where you are going to get what do you want to publish. So it is not as difficult as you might think by looking at just the code, because you can start from the UI and just copy it from here and put it into code. And now you have a code which can be put into a Git repository. Now, speaking of that, let's move over to Terraform Cloud and create a new workspace. Now here you could integrate with your version control system. I want to make sure that we are on time. It looks like we are. Here I have a repo in GitHub, and I'm going to pick this, and let's just change Terraform Splunk demo. And we will create a workspace. Now in the settings, you can use the latest version of Terraform, or you can, our provider is backward compatible. You could use any other version. So now we can go over and look at create a plan. Now it is looking at my code that I have checked into GitHub repository. It is looking at, so I have to set up, that's correct. So I have to set up a variable. Now there are two types of variable, environment variable and Terraform variable. So let's set the environment variable. And there are two variables that we have to set. We have to set auth token. And ideally in production environment, you should get this from Vault, HashiCorp Vault. And I will add another variable, which is the API URL. And that is api.us1 signalfx. Now with these set, we can run a plan. Now this time it is running, it is executing, it is actually previewing what Terraform is going to create. So it is not getting set for some reason. Auth token, did I save it? Variables, auth token. I have a backup plan. This happens in live demos. So I can create this in my Terraform, right? So if I, now it is doing exactly the same thing. It is previewing all the steps that it is going to create. Now, what we could do after we look at the plan is Terraform apply. Now, at this point of time, it is going to create, it is asking me for confirming. At this point of time, it has created all the assets that we described. So we are going to take a look here and going to go to my dashboards. So it created the sample chart. Remember, the sample chart was not there. So we just created using Terraform. And it created this very good looking dashboard group with multiple charts in there. Right? We have total number of hosts, we have number of transactions. This is the code that we were looking, minimum, maximum, and P50 latency of my customer transactions. We have total number of transactions, we have histograms. All this is created using code. Now we can fine tune this code and we can check into a repository. So you just saw within few clicks, we can create all the assets that we have in Splunk infrastructure monitoring as code. So that's all we had for the presentation today. Let's see if there's any question. Cool.
Hi. So we did receive one question right here. Well, it's actually a two-part question. Harrison asks, does the Splunk provider for Terraform support Splunk Cloud? And if so, what resources are supported? Do they support ACS? And will there be more resources supported in the future?
So I don't remember from the top of my head what all resources are supported. If you go to the documentation to the official Terraform registry, there are 3 Terraform providers that are part of that registry: Splunk as a Splunk Enterprise, Splunk Cloud, SignalFX, which was a Splunk infrastructure monitoring, what we saw today, and VictorOps. So I would refer you to that documentation to see all the resources that are part of that Terraform provider. And I'm sure these are getting updated on a periodic basis.
All right, and looks like we just got another one in, but this will probably be our last question for the day. Juan asks, does this only work with Terraform Cloud?
So I think it is directed to me. As you saw, there was an error in setting up that variable. So clearly it works with Terraform Cloud, but also I ran the same program or same Terraform file with open source Terraform that you can get from the open source implementation. So it works with open source Terraform Cloud. The primary benefit of using Terraform Cloud is state management, right? So Cole talked about state. So you have this remote storage of state, and Terraform Cloud will have all the permissions and privileges using SSO on when to lock and unlock state of infrastructure.
And real quick, Juan did send a follow-up. He said, what about if a user makes changes on a dashboard? Those changes are replicated in the Terraform code?
That's a great question. How do you keep in sync if somebody's making changes from the UI to Terraform Cloud, or Terraform code, HCL file or .tf file? Now that is not possible because it is no magic that you change in the UI and your TF file in GitHub will get updated. What we give you is a utility that if you develop an asset using UI, you can expose it as code. So you run that Python file, it will emit a .tf file for you. So you can start with that. You can start making changes there.
Well, outstanding. So that's all the time that we have today for questions. I'd like to thank our panel for taking the time to be with us today. And any questions that we received that we were unable to address live on air today, those questions will be forwarded over to our speakers after the fact, and they can email you regarding those questions. A quick reminder that today's session was recorded. So following this webinar, you'll receive an email with a link to access the recording on demand. You can also find the recording living on the DevOps website. So just visit devops.com/webinars and look in the on-demand section. Now on to the 4 winners of our 4 $25 gift cards. Our first is Benir P. Congratulations, Benir. Our second winner is Arturo K. Congratulations, Arturo. Our third winner is Angel K. Congratulations, Angel. And our fourth winner is Karthikeyan S. So congratulations to Karthikeyan and the other 3 winners of our $25 Amazon gift cards. Amit and Cole, again, thank you so much for taking the time to put together this program and your respective demos. Do you have any closing remarks before we officially close out?
I think we are at the top of the hour. Thank you, everybody, for joining. Thank you, Cole, for presenting about Terraform. And thanks.
Thank you.
Excellent. Well, I'd also like to thank you, our audience, for being with us for the entirety of today's presentation. This is Cody J. Brown signing off. Have a great day, everyone.